Hello, welcome back to Oracle DBA tutorial. In this tutorial, we're going to discuss about how a commit and rollback processed in Oracle. And we just want to discuss a little bit of internals of this mechanism, how a commit and rollback works. So before I want to do, I just ask you a question. So the question is like this. Let's say I'm doing insert. So insert into say very table T. Let's say I insert a value 1. Okay. And then my question to you is that how long does this insert is going to take. Okay, so if I do, so this is a transaction, so transaction 1. In transaction 1, I'm doing insert into table T1 and then I'm giving a commit. My question to you is that how much this commit is going to take. And to extend this question, let's say I have another transaction called T2. In T2, I'm inserting into table T1, then again I'm doing a second insert and doing a commit. And how long this commit is going to take. And let's say I have another transaction T3. T3 is going to insert say 100 times I1, I2, I3, then does a commit. Okay, so I100. So transaction 3 is doing 100 inserts. Transaction 2 is doing 2 inserts. Transaction 1 is doing 1 insert. My question to you is that the time it takes to commit transaction 1, let's say that time is X. Will it be 2x, or this is 100x, or it will be something similar to x. So my, or in other words, is that Dutch commit time depends on number of inserts. There are two things here. One is the time to commit. Another thing is the time to the transaction to complete. Obviously, you are inserting 100 rows here in transaction T3. Definitely, the transaction time will be more. But my question is precisely if the commit time will be, you know, will be more in this case, or it will be more in this case, or it more in this case, or it will be same. So I don't want to basically you just you just think about that, and you can pause my video right now because I'm going to tell you the answer after that. Okay, I hope you got the right answer. So let's try to understand what is really going on when we are doing a when we're doing this insert, and then we're going to show you a demo that we are why it is. So if so the answer is the commit time will remain constant. That means commit time is flat. It does not depend on how many number of insert or update or delete is there. It will always remain constant. And then why is that? So let's try to understand. So whenever we are doing in the transaction T100, right? Sorry, T3. In T3 transaction, we are inserting 100 rows I1, I2 up to I100. So at that time, what's going to happen is that this is our SGA. In SGA, I have buffer cache, and then I have redo buffer cache. Okay, so this is my buffer cache, and this is my redo buffer cache. Okay, so whenever I'm doing an insert I1, so what it's going to do is going to basically make a buffer dirty. Okay, and then whatever information is required to redo this this transaction, this insert is going to be stored in the redo buffer, and whatever information is required to undo it will be stored in undo location of the buffer cache. Okay, and then insert 2 is going to happen. Again, I'm going to dirty one more buffer cache element, and then also I'm going to have the equivalent redo for that insert 2, and also I'm going to have equivalent undo for the insert 2. This keeps going on. Eventually this redo log buffer, log writer will come to play. Log writer is going to write from the redo buffer cache to our online redo log file. So this is our online redo log. Okay, so LGWR is going to flush the redo buffer cache based on three conditions, either in 3 seconds or 1/3 of the space is filled, or on commit, because we are not doing a commit yet. Okay, eventually maybe after, let's say if the buffer cache, if this is very small, then maybe let's say after 10 insert I'm going to fulfill this condition that 1/3 is filled. So if 1/3 is filled, then log writer is going to write to the online redo log file. Also it may happen that there might be a checkpoint. Okay, so there might be a checkpoint, and because of which, or another case is that, let's say this buffer cache also is going to filled. If the buffer cache is going to fill, then db writer is going to write to the data files. All the all the data block buffers are going to be written to the data files, and all the undo elements are going to written to the undo file. Okay, so essentially while this insert is going on, so we are already doing all these things. Now like whenever we are reaching the 100th insert, after that we are giving this commit. So when we are doing the commit, so following things will happen. A SCN number is generated, that is called system change number is generated for this transaction, and then log writer is going to write the remaining leftover buffers in the redo buffer cache. Okay, so the remaining buffer redo buffer written to online redo log file, to online redo. Okay, then whatever logs are acquired being released, and so logs are, and this is what commit does. If you see, before commit we are doing the major work, like we might have done, like if there is 100 insert, we might have done couple of times, log writer might have written. So that means during that time we have almost done 99% of our work before even we do the commit. And the moment we do the commit, we are just saying that we are done, and whatever the remaining amount of writing to be done will be done. Remember, that is why if you insert one row, or if you insert two row, or if you insert 100 rows, doesn't matter, because most of the work done during the insert, and during the commit only it will do a SCN number and remaining blocks. So therefore, if I measure how much time this commit statement took, it will come as a flat value. So just to show you that really happens, let's take an example. So here is a PL/SQL code. In this PL/SQL code, what I'm doing, I'm basically in a for loop, I'm inserting to the table T the value. So I have a very simple table T which is contains just only one column, and then after in this for loop I'm inserting 10 rows or 100 rows or 1000 rows, and after that, just before commit, I'm taking what is the time right now. By using this PL/SQL package, I can get the current time. I put that one in start time, and then I'm going to do basically get again the time after this commit is done, and then I will deduct from my end time, and then I'm going to show you how much time does it take. And after that, I'm just going to delete the table T so that I can show you the next case. Okay, so if and this is a very straightforward PL/SQL procedure. I just want to run that thing in the. Okay, so let me just try it. Okay, I didn't select it. Okay, Control C, Control V. So now whatever this this timing is going to show, is going to show me for 10 rows. So let's. Okay, so the time taken looks like 0.02 second. All right, so now let's edit again, and let's say I want to, so just for information, so for 10 rows it took 0.02 second, and let's try to do it for 100 rows. So again it takes for, so like, okay, I didn't modify that one. So let's say I want to do for 100 rows. Let's see how much time it takes. This takes about 0.00 second. Let's say I want to do it for 1000 rows. This again takes 0.00. So for 1000 rows, it take again 0.00. Let's say I'm going to do for 1000, 10,000 rows. It takes some time because it's going to insert 10,000 times. Okay, so again it's give me 0.00 second. Okay, so it's again going to give me for 10,000 rows. So let me write it in a clean place. Okay, so for 10 rows it took 0.02 second. I'll tell you why it is a abnormality in the data. And for 100 rows it took 0.00. For 1000 rows it took 0.00. For even 10,000 rows it took 0.00. This is a abnormal data because I just, I'm just, I was trying to do after a, like, just for this purpose remove this data. Okay, so now let's say if I'm going to do a 10 rows. Okay, so let's try to get another time. So let's try to insert only 10 rows now. Then I hope it's going to give me, okay, 0.00 second. So the 10 rows, so the initial data I got was not, database was not warmed up, so I can ignore that one, and I rerun 10 rows and it is giving me 0.00 second. So essentially, even if I insert 10 rows, 100 rows, 1000 rows, or 10,000 rows, the commit time is always 0.00 second. That means, like, in this program I'm trying to capture the commit time up to 5 digit. Okay, up to 5 digit precision, and I'm not able to get anything. Maybe, like, if I go for more precise calculation, maybe I'll get. But my point here to just to show here that even I insert 10 rows or 100 rows or 10,000 rows or 10 million rows, the commit time will be always the same. Okay, and the reason is most of the work is being done before the commit is actually happening. So now let me ask you another question. How long does it take to roll back? The question is, how much time it will take to roll back 10 rows, 100 rows, 1000 rows, or 10,000 rows. Okay, so is the way that we see the commit time was flat, is it going to be flat or it's going to be something different? Okay, so why don't you do something? Why don't you just first run, like, basically we are going to run that program, and we are going to do rollback, and we're going to see, like, how long does it take to roll back 10 rows. So this is my rows, this is my time. Then how much it takes to roll back 100 rows, how much does it take to roll back 1000 rows. Okay, so this is the program. What I'm going to do, I'm going to roll back here. I'm going to modify, instead of commit, I'm going to use rollback. So in this case I'm going to roll back 10 rows. Okay, okay, so before that, let me see, like, how many rows are there. If anything rows I need to delete. Okay, select star from T. Okay, there's no rows. Okay, so I'm going to do, okay, so this is the PL/SQL program that I'm going to write now, and then so basically it's going to declare and all those things. I'm going to roll back 10 rows. Yes. Okay, so time taken to roll back 10 rows is 0.00 second. Okay, so let me just write it down here. The time taken to roll back 0.00 second, and let's say how much it takes to, now let's edit and let's try to we are inserting 100 rows, and then we're rolling them back, right? Looks like it takes 0.03 second, right? So for 100 rows it took 0.03 second. Let's say we want to roll back 1000 rows. This takes 0.09 second. So what's going on here? So essentially what we are saying, the more number of rows we are trying to rolling back, the time to roll back is increasing, right? So like if I draw a graph, say this is rows and this is time, for commit it is a constant. Okay, so this is this kind of graph that we are going to create if you want to measure the commit time. If you want to measure the rollback time, and these are number of rows and time, so it looks like you're going to get some kind of graph that is increasing, right? So as the some maybe a linear graph or this thing, I don't know, but with time, so with number of rows to roll back, the time is going to increase. Why this is so? To answer that question, let's try to understand what really happens in the rollback. Say like what we have in our code, right? So we are, let's say we are inserting two rows, I1 and I2. So whenever inserting two rows, again let's draw that SGA. So we have, this is our buffer cache and this is our redo buffer. So it's very simple SGA, and a lot of things, other things are there I'm not considering right now. And then whenever I'm going to insert, I'm going to dirty one buffer here and then create necessary redo logs and also create necessary undo logs in the buffer cache. Okay, then whenever I'm going to I2, I'm going to have another buffer dirty, then I make the necessary redo buffer and also I have an undo buffer, and this goes on. Eventually, and all this is going on, and then also we have a data file. So this is the data file, and then also we have undo segment, undo file, and also we have online redo. So this LGWR is going to write this from the rollback buffer at the right time, and then so this is going on. Let's say after that, whenever I am saying that after inserting 10 rows, I am roll back. So when I'm going to roll back, what rollback is going to do? Rollback is going to read the basically going to revert all this 10 inserts back. That means since it's inserting, is almost going to do a delete. The opposite of insert is delete. So therefore, the rollback is going to make sure that whatever happened, those things will be reverted back. Actually, whenever you do a rollback, we are going to read from the undo area and then copy it to the buffer cache. Since we are doing here 10 rows, so we are going to do the work, whatever work to from undo to dirty buffer is going to be done 10 times. Let's say if one time is take x time, then 10 times will take 10x time. Now imagine we are going to roll back 100 rows. That means 100 times we are going to do the same operation of rolling back. That means as the number of rows being inserted goes in, keeps increasing, then there are more and more works needs to be done while doing the rollback. And that is the reason why rollback is going to be dependent on how many number of rows that you are going to rolling back. All right, so this is what is the essence of rollback and commit. And another thing from yours is that you don't have to really, a lot of people think that if they commit faster, then the the commit sooner, then the things will be the application will be more scalable and all this thing. That's just a myth. Okay, so what I think you should do, because you see the commit does not take so much time. Okay, so what you need to do, you need to do at right time. Whenever, just think about always about, don't do commit pretty soon, or don't delay it. So whenever you finish your logical unit of work, then only you do a rollback, sorry, do a commit, or if it does not work, then roll it back. Don't wait more, or don't do it fast. Okay, so that is the strategy that you need to do whenever you develop an application. Think about what is the logical unit of work, and based on that, you roll back or commit.